Stoichiometry gram-to-gram conversions. Stoichiometry is a branch of chemistry that deals with quantities or amounts of reactants and products in a chemical reaction. And typically you're given the grams of a reactant and you have to figure out how many grams of product will be made, or you want to figure out how many you know how much grams of product you want to make, and you have to figure out how many grams of reactant you need in order to make that many grams of product. Let's say you're given this problem. If 5 grams of potassium reacted with excess water, how many grams of hydrogen gas would be produced? The following balanced equation is given. 2 potassiums plus 2 waters yields 2 potassium hydroxides plus 1 hydrogen gas. In order to solve this problem, I would first draw a set of boxes underneath potassium, 3 boxes underneath water, 3 underneath potassium hydroxide, and 3 underneath hydrogen. And I'd leave a set of 4 boxes and an extra long box underneath in order to try to figure out what's knowns, unknowns, and will be our map in order to try to solve this problem. In the box on the left, I'd first write grams, molar mass, moles, and then molar expressway. I would then fill in your knowns and unknowns. So if you read the problem, you're given 5 grams of potassium, so that's one of your knowns. So underneath potassium, I would write 5 grams of potassium because that's your known. And what are you trying to find? It says how many grams of hydrogen gas would be produced. That's what you're trying to find. So your unknown, I would write over here as grams of hydrogen gas. That's what you're trying to find. And in this problem, what we're going to do is we're going to use these boxes as a map, and you're going to have to go from grams of potassium to moles of potassium. That's your first step. Then you're going to have to go from moles of potassium to moles of hydrogen. That's going to be your second step. You're going to use the molar expressway. And then you're going to have to go from moles of hydrogen to grams of hydrogen, and that's going to be your third step. First, you have to make sure you have a balanced equation, which in this problem you do have a balanced equation, so you are okay with that. So you're going to use this sort of U method in order to solve it, going from grams of potassium to grams of hydrogen for this problem. Our first step is to go from grams of potassium to moles of potassium. In order to do this, we need to find the molar mass of potassium. If you look on the periodic table, you should find that the molar mass of potassium is 39.10. So what I'm going to write is 1 mole is equal to 39.10 grams of potassium. And the molar mass always comes straight from the periodic table. In order to solve for moles of potassium, we take our known, which is 5 grams of potassium, and we use dimensional analysis, and your conversion factor is going to be the molar mass that you just found out. On the bottom, you're going to put 39.10 grams of potassium, because that's the grams of potassium. These units need to cancel. What you start off with, that unit always has to be in the denominator on the bottom, always. And on the top, we're going to put 1 mole of potassium because that is the other part of our molar mass. Alright, when we do these calculations, the grams of potassium cancel, and we're given 0.127877 moles of potassium. Now we have to convert moles of potassium to moles of hydrogen, and the way that we do this is we use what I call the molar expressway. On this molar expressway, you use information straight from the balanced equation related to potassium, and now we're in the hydrogen column, and hydrogen. Well, if you look at the balanced equation, you have 2 moles of potassium in the reactants and that's going to make 1 mole of hydrogen gas in the products. So for our molar expressway, I'm going to write 2 moles of potassium that came straight from the balanced equation is equal to 1 mole of hydrogen gas. Also straight from the balanced equation. There's no number in front of hydrogen gas, so that means that's a 1. What does this mean? Down here in the molar expressway, for every 2 moles of potassium reacted, 1 mole of hydrogen will be produced. If you know that for every 2 moles of potassium, 1 mole of hydrogen will be produced, and you know that you have 0.12 moles of potassium, well, you would expect that you would have about 0.06 moles of hydrogen produced, about half the amount, because for every 2 moles of potassium, you're only going to get half that amount of hydrogen, 1 mole of hydrogen. So in order to solve this, you know your moles of potassium. You're going to write that amount of moles of potassium. You're going to use the information from the balanced equation or the molar expressway, and you're going to make that's going to be your conversion factor. Make sure you put moles, the 2 moles of potassium on the bottom, so the units moles of potassium, those cancel, and you're going to put the 1 mole of hydrogen gas on top. So moles of potassium cancel. Now 0.127877 times 1 divided by 2 gives 0.063938 moles of hydrogen. So you will write that number in the moles box under hydrogen, 0.063938 moles of hydrogen. Now that we know how many moles of hydrogen that will be produced when reacting 5 grams of potassium, it's easy to figure out how many grams of hydrogen will be produced. In order to get from moles of hydrogen to grams of hydrogen, we need to find out, well, what's the molar mass of hydrogen? The molar mass of hydrogen, you need to always find the molar mass using the periodic table. Well, you know that hydrogen on the periodic table, the mass is 1.01, but we're working with hydrogen gas, H2, so you have to double that amount, so that's going to be 2.02 grams of hydrogen per mole of hydrogen gas. Another way to write this is for every 1 mole of hydrogen gas, that's equal to 2.02 grams of hydrogen gas. That's how much 1 mole of hydrogen gas weighs. Then you write this conversion factor in the box for molar mass. So knowing the moles of hydrogen and knowing the molar mass of hydrogen, we can find out the grams of hydrogen gas. So I'm going to write 0.063938 moles of hydrogen. You're going to use this as your conversion factor, the molar mass. So on the bottom you put 1 mole of hydrogen, and on the top 2.02 grams of hydrogen. The moles of hydrogen cancel, right? You have to have moles cancel out, the same unit cancel, and you're left with 0.1291557 grams of hydrogen. So using this U method, you're able to calculate how many grams of hydrogen will be produced, knowing the amount of grams of potassium that is reacting in the reaction. The last step is to find out the amount of significant figures in your final answer. If you start off with 2 significant figures in the original problem, and the final answer has many, like you need to convert that to 2 significant figures, you take the 9 and you round the 2 up to 1.3, and that's going to be your final answer. So your final answer is 0.13 grams of hydrogen gas. Well, I hope you learned a lot about doing gram-to-gram conversions in stoichiometry. I also want to let you know that it's possible, if you're given this, the 0.13 grams of hydrogen gas, and you don't know the amount of potassium, you can do the reverse method, converting grams of hydrogen to moles of hydrogen to moles of potassium, and moles of potassium to grams of potassium. So it's sort of a reverse U. In order, if you're given the amount of product and you need to know the amount of reactant. So you can go this way, or you can do the U the other way. Either way will work. It's the same steps that you need to do. It's just the reverse way. Okay. Have a good day.